Welcome to The Explainer. Today, we're diving into a really revolutionary idea, one that could totally rewrite our understanding of life itself. What if the very engine of biology, deep inside your cells, is actually running on the strange and incredibly powerful rules of quantum mechanics?
So get this, right now, deep inside your body, there are trillions upon trillions of tiny biological machines hard at work. And these little nanomotors that read and write your DNA, well, they operate with a level of efficiency that is almost unbelievable. Okay, so to put that into perspective, think about your car's engine. It's doing great if it converts, maybe 40% of its fuel into actual motion? But these biological machines, they're hitting nearly 100%. So, what's their secret? That's the question that has kept scientists up at night for decades.
And it's not just about efficiency, it's about sheer, raw processing power. In just the 10 milliseconds it takes for one of these little machines to read a single letter of your DNA, it performs what's been estimated as 100 billion computational steps. Let that sink in.
That kind of performance, it just doesn't make sense if you're only thinking in terms of simple chemistry and molecules bumping into each other. It really suggests there's a deeper layer to the story here, a physical principle at work that we just haven't fully accounted for in living things.
So what is that missing piece? Well, physicist and physician Dr. Anita Coley has a pretty radical hypothesis. She's proposing that life isn't just passively following the laws of physics, it's actively harnessing the most powerful and counterintuitive part of it, quantum mechanics.
And this idea isn't entirely out of left field. The original architects of quantum theory, people like Einstein and Schrödinger, they actually suspected that life held the key to completing their own physics. They had this feeling that something was missing, and that biology was the place we should be looking for the answers.
But for a century, there's been this one massive roadblock, the big objection. See, you gotta think of quantum effects like these super delicate soap bubbles. To exist, they need really cold, quiet, isolated conditions. A living cell is the complete opposite. It's warm, it's wet, it's chaotic. That environment should pop the quantum bubble instantly. Physicists have a name for this problem. They call it decoherence.
But here's where it gets interesting. Recent calculations are suggesting something pretty remarkable. For these DNA motors, the quantum state might just hang around for a few orders of magnitude longer than the time it takes to do its job. It lasts just long enough to matter, just long enough to make that crucial difference in its incredible efficiency and speed.
Okay, so it's a great hypothesis. But how in the world do you actually prove it? You need an experiment that is so definitive that it leaves absolutely no room for doubt. You need the ultimate litmus test for the quantum world.
Now, in physics, that gold standard is the double-slit experiment. The setup is pretty simple. You fire particles at a screen with two slits in it. If you watch them, they act like tiny little baseballs and make two bands on the wall behind. But here's the magic. If you don't watch them, they stop acting like particles and behave like a wave, creating this complex, rippling interference pattern. That wave pattern, that is the undeniable smoking gun fingerprint of quantum mechanics.
And that leads us to the core of the whole proposal. Dr. Coley has laid out a roadmap for a biological version of this legendary experiment using the very same nanomotors that copy our DNA. If these living machines can produce that quantum interference pattern, well, that changes everything.
Because if life is proven to be a quantum phenomenon, it means our current physics, the one that served us so well for over a century, is missing a key ingredient. It means it's fundamentally incomplete.
The old way of looking at things views reality as this grand dance between matter and energy. This new physics says there's a third dancer that we've been completely ignoring: information. And here's the really radical part. It's not just abstract data. The idea is that information is a physical, fundamental component of our universe, just as real as a rock or a ray of light.
And this is a brilliant way to picture how it might work. Think of your DNA as a piano. The sequence of genes, those are the keys. But what actually plays the music? It's information from the environment, the milieu, that acts like fingers on the keys, determining which genes get expressed and how. This could even explain things like why two people with the exact same cancer gene can have totally different outcomes.
Okay, and this is where things get truly profound. This new physics of life has its biggest implication for what is arguably the greatest mystery of all, our own consciousness. The conventional story in science, right, is that consciousness is what's called an epiphenomenon. It's basically an accidental byproduct that just kind of emerges when matter, like the neurons in a brain, gets complicated enough. So matter is the foundation, and consciousness is just the tiny little tip of the pyramid.
But this new paradigm, it takes that pyramid and flips it completely upside down. And this is a truly mind-bending shift. It suggests that consciousness isn't an afterthought, it's the foundation. It's fundamental to the very fabric of reality, and things like matter, energy, space, and time, they are what emerge from it.
Now, this isn't just some abstract philosophical idea. Adopting this worldview could actually be the blueprint for the next great leap forward for humanity, a fifth industrial revolution. Think about it. The fourth industrial revolution, the one driven by AI and data, is the logical endpoint of a purely materialistic worldview. It's all about utility and efficiency. But a fifth revolution, one based on consciousness, would be built on things like purpose, interconnection, and a much more holistic view of what progress even means.
And this isn't just philosophy. We're talking about massive real-world consequences. Imagine a healthcare system that treats the body's information field just as much as its chemistry, or technologies built on the very same quantum principles as life itself. It's about bridging that artificial gap between the observable world of science and our inner world of experience, and fostering a world where we finally recognize our deep connection to each other and to the planet.
So, the crucial point is really this. If the tiniest machines inside our own cells are tapping into the fundamental weirdness of the quantum world, it forces us to ask a much, much bigger question. It suggests that life isn't just some random accident, but maybe a profound expression of the universe's informational fabric, pushing us to ask, what is nature trying to tell us about ourselves?